The efficiency of an electrical generator is 65%. 65% means 65 divided by 100, which is 0.65. Okay. The energy input is 12 joules. So this is the total input energy. What is the useful output energy? Output energy is how much? So we know that efficiency is output energy over input energy. So efficiency is 0.65 and output is unknown, input is 12 kilojoules. So if we move 12 to the other side, it would be 12 times 0.65, which is our output energy. So 12 times 0.65 by using calculator, it would be 7.8. So the correct option is this one. Coal is burned as a fuel to heat water in a boiler. It's a fuel engine type of thing. Coal engine. Producing steam. Like we know that in our power plants, coal is burned as a fuel and the heat is given to the water that convert water into steam, and the steam is used to run the steam engine. Steam engines are connected with turbines that runs the turbines. Turbines are connected with electrical generator which convert mechanical energy, or their kinetic energy of turbine is converted into electrical energy. So coal is the first stage and coal contain chemical energy. So let's start with chemical energy. And chemical energy is converted into heat energy. Okay. Heat energy is given to turbines which runs, and that is connected with electrical generator that generates electrical energy. So we have, this is our correct option. Okay. A crane moves its load diagonally as shown in figure. Okay. By which distance is the weight of the load multiplied to calculate the change in gravitational potential energy of the load. Okay, I think the function of turbine is something like that. Suppose this mm, this crane. This crane is working something like this. Like as the load moves here, it actually moves little in upward direction as well. Like this. When it will be here, the load will be little upward, something like this. Then when it will go here, it would be somewhere here. When it will be here, it will be something like this. So you can see initially this okay, here, and now you can see this much is traveled, this much distance or height is traveled. So this moves in this like this portion moves in this direction, along with it moves little upward in direction. So the height is traveled. This much height is responsible for gain in potential energy. So when okay, when this crane moves in this direction, along with it, the load starts moving in upward direction like this, and it reach here. So actually, this amount, this height is traveled by this load, and we are looking for gravitational potential energy. So for gravitational potential energy, we are looking for only height. So the height b is traveled by the height b is only traveled by this load, which is responsible for gravitational potential energy. A parachutist has opened his parachute and is falling to earth at constant speed. Constant speed is terminal velocity. What is the principle of conservation of energy taking place as he falls? Like you know that suppose here is a parachutist who is coming like this. Okay. Parachutist is coming in downward direction. So you can see when it would be at certain height, it will have it will have potential energy only. Okay, here is suppose here is ground, and the parachute is coming from this height. The parachute is coming from this height and is going in downward direction like this. At this point, it will have only potential energy when it would be in state of rest. When the parachutist will jump, it will have kinetic energy as well. So at this point, suppose at this point, it will have both kinetic and potential. At this stage, both kinetic potential. At this stage, both kinetic potential. Even at this stage, both kinetic and potential. But when the parachutist will reach here, it will have only potential kinetic energy, because potential energy is converted into kinetic energy is converted into kinetic energy. So initially it will have potential energy that would be converted into kinetic energy. So potential energy is here, potential energy is here. So both are potential energies. Next is potential is converted into kinetic energy. And here is thermal energy, which is incorrect. So overall, we have this option, which is the correct option. A small emergency generator supplies this much energy of electrical energy in 24 hours. Okay. Okay, this is amount of energy, and this is time. What is the average power of the generator? We know that power is energy per unit time. Power is energy per unit time. So energy is some 432, and there are 6 zeros. And time taken is 24 hours. In 24 hours, we have 86,400 seconds. So let's divide them. 432, 1, 2, 3, 4, 5, 6 zeros divided by 86,400. And the answer is 5,000. So power is 5,000 watt. Okay. The diagram shows a curved track. This is the curved track. A ball is released from the position as shown. Okay. So we can assume that, suppose this is the ground level for this ball. This can be the ground level for this ball. And the ball is at some height at point A. It will have like, if it is in rest state, yes, it is held by someone. So it will have maximum potential energy at this point. When the ball is rolled down, released, it will move here, 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 like this. It will go something like this. Okay. So when the ball is rolled down, its potential energy decreases, 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 and that is converted into kinetic energy. And at this point, it will have maximum kinetic energy, and then again. At which point does the ball have the maximum gravitational potential energy? So you can see Uh, let's compare the points. So we can see the A has the maximum height, means maximum gravitational potential energy. Then B, then this one is C, then D. You can see A, then D, then B, then maybe C. So the maximum gravitational potential energy is at A. A is the point where gravitational potential energy is maximum. When one radium nuclei decays, its mass is this much. How much energy is equivalent to this losses in mass? So when it decays, the radium nucleus is decreased by this amount. It means this amount is converted into energy. So we are going to convert this lost mass into energy by using Einstein equation. Einstein equation is E equals mc square m is and c is 8 whole square. So 10 to the power minus 30 plus 16. So it would become 8.8 multiplied with the 9. It is 79.2 into 10 to the power minus 22. So it can be 7.9. Oh, 30 minus 30 plus 16 is not 22. It is 12, 14. So if we rearrange, it would become 7.9 into 10 to the power minus 13. So we have correct option, which is D. D is the correct option. The energy output of a generator depends on the efficiency and energy input. Which set of values is correct? Okay. Energy input, energy output. So the formula for efficiency is output over input So output is 25 and input is 50. So answer would be 0.5. So this option is incorrect. Similarly, 6 divided by 30, 0.2. This option looks fine. 6 divided by 30 is 0.2. Now 30 divided by 120, 0.25. So this value is incorrect. Now 24 divided by 60, which is 0.4. This is also incorrect. So we have only one set of equation, one set of values which is correct. It gives correct answer. Okay. Which process is in the sun produces energy? We have already discussed it, that in sun we have nuclear fusion process which is responsible for energy production. Again, there is a similar type of question. A crane lifts a load 1000 Newton through a vertical height of 3 meters in 10 seconds. The input power to the crane is 500 joules per second. 500 joules per second. Joules per second is the unit of power. So input power is 500 joules per second. What is the efficiency of the crane? So let's calculate the first. Here is a weight and height. So weight into height is potential energy. Weight is 1000. Height is 3. So it is 3000. And power is potential energy over time. So potential energy is 3000 over time is 10 seconds. So it would be 300. Okay. Now this is our output power. The input power is 500 joules. Now let's calculate efficiency. Efficiency is output power over input power. So output power is 300 and input is 500. So 0 is cancelled with 0. 3 divided by 5 is 0.60. So our answer is 0.60. So we have this on. This is our answer. Okay. The diagram shows energy transfer through a machine. Input is given to this machine, and some of the input energy is converted into useful output energy, and some of the energy is wasted. What is the efficiency of machine? Efficiency is useful output divided by input energy. So useful output energy, this is input energy, that's wrong. So here is wasted energy, that is wrong. Wasted energy has no concern with efficiency. So there is only a link of useful output energy to the total input energy.